but it's different. This is water, okay, and it melts and it evaporates. This, do you see anything dripping?
No.
No, do you see what looks like steam coming off of it? Yes. This is a solid that's going right to being a gas and going right into our environment. We don't call this evaporation. When it goes from a solid to a gas, we call it sublimating. Can you guys say sublimating?
Sublimating.
And this isn't made of water. It's made out of carbon dioxide. Okay? And it's a byproduct of other things that people make. And then you have smart people who collect it, they condense it and push it together and put it under temperature, and it forms, okay, a block or a solid that is negative 109 degrees. Now this ice is 32 degrees Fahrenheit, which is the freezing point. This is even colder. It's so cold I can't touch it. And it's turning my metal tongs, it's freezing them. And if I touched it, it would hurt and it would look like a burn and it would blister. Okay, so we don't touch it. But we know that we can use it for all sorts of things. Shipping food, for example, or doing really cool experiments. Should we try?
Yeah!
Okay, so let's see. I'm going to put, it is dangerous in the sense that if you're not careful and you grab it, you can burn yourself. So I'm going to put a little bit of water in here. This is what we call lukewarm. And luke comes from the British word luke, L-E-U-K, that means tepid or room temperature. I do that because this glass is a solid, but it's a fragile solid. And when I put something that's that cold in it, it'll crack it instantly. Okay? How's that for a chemical reaction? Okay, can you guys count down with me? Ready? 3, 2, 1.
That's unimaginable.
And let's see if we can speed it up a little and use some temperature. Okay, so
Oh
here's
no.
the temperature.
It's already
And we
passed
have
away.
hot. Now that hot
Guys,
is
gonna
going to
blow.
touch my cold and it's going to speed
Gonna
it
blow.
up, okay, and create more kinetic energy. Okay, let's see. Whoa!
Glass is breaking.
Okay, so this is a chemical reaction
Glass is
that's
breaking.
affected by temperature.
Glass is
Okay,
breaking.
just like my ice.
How are you
Because
touching
the
it
room
now?
is at 32 degrees, so it's
Glass.
naturally going to change. The atoms and molecules are going to change. Okay, now, I have a good idea. I'm going to put some Dawn dishwashing soap.
Oh god.
Bubbles
That's
are
not
the
good.
theme for today.
It's not a good idea. I think
So
it's a good
bubbles are
idea.
interesting. Bubbles are like a sandwich. They have a layer of soap, a layer of water, and another layer of soap. Those atoms and molecules put pressure on each other. That pressure creates the walls that make a bubble what shape?
Sure. Sphere.
A perfect, beautiful sphere.
Yes.
And when those spheres
Me, what
touch
about
each other, they create a wall that has the perfect six-sided shape. What is a six-sided shape?
A hexahedron.
What?
A hexahedron. Hexagon. Hexahedron. Hexahedron's a three-dimensional shape.
Let's see what's going on here. So let me get my,
Now it's morning the teacher.
okay, and we're gonna put this in here
Blow it up,
gently.
blow it up, blow it up, blow it up, blow it up.
Okay, and add the
Blow it up,
temperature.
blow it up.
Are you ready?
Yes! Blow it up!
Backwards.
3, 2, 1.
Wait for it. Wait for
It's like
it.
explode.
I'm still waiting for it. I'm still waiting for
That could
it.
happen.
Okay, then maybe we just add more.
More.
See? Where is it? Okay, we're gonna wait, we're gonna watch it. You're all gonna yell out when the bubbles do come up. Okay, so then I'll know. Okay, so, what's that? More water? Mr. George says more water, why not? Let's see.
Oh.
Oh! Look at that! And these bubbles are filled with carbon dioxide gas.
Actually,
That's why
it's
they're
just-
white.
it's just the opposite
Check that
version.
out. Thank you, Mr. George.
It's the
And
opposite.
now,
It's the opposite
that is
version
a
of
solid
elephant
to a
toothpaste
gas.
because elephant
Okay,
toothpaste is
what is in
over
here?
100
Is it
degrees.
a solid, a liquid, or a gas?
Liquid.
Because the atoms aren't that far together, there's more space in between them. But I'm going to change this liquid into something that's also a solid. What? It's going to be a liquid and it's going to be a solid.
Oobleck.
We call that.
Oobleck.
We don't call it We
just
call
like
it a polymer or a non-Newtonian fluid.
Oh,
If we have
non-Newtonian.
time, I'll tell
You
you.
seen this
But
What?
this is chemical reactions at its best. This is sodium bicarbonate. I call it sodium bicarbonate. You call it baking soda. Okay,
What it
baking
is?
soda is the bridge. It's the connector. Okay, and I'm gonna stir it in.
Yes,
And
it
stir
was
it.
like it's just
Okay,
like shattered.
is it a liquid, a solid, or a gas still?
Liquid.
Still a liquid. Then I need to put in the magic ingredient. It looks like water, but it's not. It's boric acid or activator. But it's called activator because it
activates
speeds up the molecules and atoms. It pushes them together so there's less space. If there's less space, what does it become?
A solid.
A what?
Solid.
Solid. Let's see.
I already know
Okay,
about all this stuff.
just a little bit goes a long way. I'm gonna mix, and look at what's already happening. Okay, already happening. If I let that sit for a minute, this is what it becomes.
Look at the bubbles.
Okay, this is,
Newtonian fluid.
you call it slime, I call it polymer. Okay, now polymer is what we
It's a
call a
Newtonian
non-Newtonian fluid. Non-Newtonian sounds like a complicated word. Non-Newtonian, because there was a guy who lived 300 years ago. His name was Isaac Newton, and he defined solid, liquid, gas. Okay, and if it doesn't fit that definition, it's a non-Newtonian fluid. This right here is a liquid because it still fits in any container, but it's a solid because I can pick it up. How cool is that? Can I get a
Can't pick up.
ooh, ah? Moving on, okay? I do all sorts of fun experiments. We talked a little bit about air. Air has all kinds of stuff in it. Air has density or mass. Okay, and in here, this is a nice little diagram that shows you most of the air we breathe isn't oxygen. It's actually nitrogen. And our bodies help filter all of that out. Okay, and
There's
the
nitrogen
closer
in our
air
body.
is to the ground,
They
the
heat
thicker
all your
it is.
earwax.
It's why airplanes have a pointy nose because it cuts through that air. Well, here's what I'm going to attempt to do.
And you
I'm
need
gonna
it
attempt
to
make
brush your
bubbles,
teeth.
And I'm going to attempt to put a gas in it that weighs less than air. Okay? If it's
Helium.
less than air, what should my bubbles do?
Helium. Love.
Now, when I turned on this bubble machine, okay, and my bubbles go up, they go up for a minute, and then what happens?
They go down.
Because of what force?
Gravity.
You guys are brilliant. Okay, so I'm gonna try and defy gravity. Okay, and I'm gonna try. and make
We're
bubbles.
breaking the law of
These
gravity.
bubbles just have air, they're gonna come down. Those bubbles have carbon dioxide steam in it. These bubbles are gonna have
Ice. Oh
helium.
God. This can.
Okay, now,
I
at
can't wait till
Challenge
this-
Island, we do experiments, okay, and we always utilize the scientific method. We make a ton of what we call prototypes. Sometimes they work, sometimes they don't. That is the nature of science. We made this prototype. It did not work. We made this prototype. It did not work. Okay, and finally, we made this prototype here with a series of pipes with holes in it. Okay, we got it on our third try. Okay, but again, science doesn't always do what you want it to do. So let's see what happens, okay, when I stick gas in it. Okay. Okay. Wait for it. Wait for it. What?
Put the bubbles in the bathtub.
What?
Break free.
What's
Break
gonna
free.
happen?
Gotta break
What?
free.
Let's
Break
see, let's
free.
see.
It's fast now.
Let's
We gotta
see.
break free.
Up, up, up.
Up, up.
Up and away.
There we go. Woo! Oh, we know it. Look how bouncy balls. Woo! It's going towards the other one.
Do not tell anybody that I'm doing bubbles on their ceiling. Don't tell anybody. Okay, now.
Guys, they're doing bubbles on your ceiling.
They are infused. Okay?
Oh! The collision.
If I were to walk around, you would see, okay, that these bubbles pressed up against each other form the perfect hexagon. It's the most amazing thing. And that's really all to do with science. the hydrogen atoms actually form a 106-degree angle, which is crazy. Okay,
Whoa,
this angle, you know your geometry, is more than 90 degrees.
Wow.
Okay, so it's
106 is more than 90. I didn't know. 160 is more than 90.
right? Okay, but of course, we have our things here. Okay, our perfect. Okay, our perfect. What shape is this?
A spear. Spear.
Okay, a perfect sphere pressing against each other to form rounded walls.
Spear. Oh,
And
that
of
one.
course, they're popping, not just because they're hitting a surface, but because the water is actually turning into a gas in front of us and it's evaporating. Because do atoms and molecules ever sit still?
No.
They're always moving, and we can affect that movement by adding other chemicals. What do we call
If I said
the
still,
process of mixing things together and making new things? We're not science or a chemical change or a chemical reaction. Well done, my friends. Okay, now we have gone from a solid to a gas, a liquid to a solid, back to a liquid, and we've gone from gas, okay, and made our bubbles blow. How is that for the states of matter and for science? Can we get a clap on that one? Okay. You guys are going to get to see some amazing, amazing things today. Teachers, make sure you grab your packet. We have a fun little activity in there that has to do with air and density. Okay, it's challenging for sure, but it's nice and simple. You're about to leave. There are going to be people in the hallway,
Challenging, but
people
it's nice and
downstairs
simple.
that can show you the direction that you guys are going in. Enjoy today. It's a nice sneak preview, and if you happen to come tomorrow, come visit our booth where we're giving away free polymer samples. I call it polymer. What do you call it?
Airblast.
I can't hear you. What do you call it?
An earbud rupture.
Thank you for everything that you do. Thank you for coming today. And
Woo! What do you call it?